Hi, everybody. Welcome to day two, droidCon. My little talk here. It's on a thing we call Doppl. It is Android-centric code sharing. This is the website where you can read all these things sort of at length at your leisure. My name is Kevin Galligan. I'm president of a company called TouchLab. TouchLab was for several years an Android-only consulting company based in New York, started around 2010. I've been doing Android since before the G1 even came out, and Java since forever. Our company runs the big Android meetup in New York, which is about 4,000 people. We also run droidCon NYC since 2014. The 2017 edition is in like 2-3 weeks, so throwing that out there if you want to check it out. The short version is lots of Android, and we're heavily involved with the Android folks. So, Doppl, it's Android code sharing, Android-centric code sharing built on J2OBJC in a sentence. So what is J2OBJC? This is a framework that converts Java to Objective-C. And when I first heard about this, it sounded terrible. And this should probably sound terrible to anybody who understands what that means. It is made by Google. In fact, the person who started it, Tom Ball, used to work for James Gosling. If you look at his LinkedIn page, he has James Gosling leaving a recommendation to him. If you don't know who James Gosling is, don't worry about it. They use it in Sheets and Inbox and a few other large-scale applications. And the reason is, talking to them, like they built this whole spreadsheet library in Java. And as you can imagine, a spreadsheet library has a lot of logic and a lot of changing and improving logic over time. So recoding that sucks, right? So they kind of built this whole thing. It is very stable. It is very difficult to use. There are no standard build tools. A lot of make files. I don't know if you edited make files anytime in the recent past, but they are terrible. And it is just logic. They really don't focus on anything outside of the code and basic stuff, right? And that's Inbox. So J2OBJC, the JRE, Lang, IO, util, and a bunch of other stuff is included in J2OBJC runtime, which runs on iOS. They have a little bit of Android, like log, but they really keep it intentionally very Android light. JUnit, Mockito, and a few other things like Guava, yada yada, right? Doppl, what Doppl is and what it adds, so we'll go through that. There is a Gradle plugin, and this is built off an earlier Gradle plugin that we started with that was abandoned and forked. It takes your code, which is Java, potentially other stuff in C++, and which you probably won't have, but you might. And then the Doppl dependencies, so anything that you've declared that you're going to need on the iOS side, and puts it in the Gradle plugin. Then your J2OBJC makes your Objective-C, and then your dependencies are put somewhere that is meaningful to your environment. So that's down here, Gradle plugin and a library format for the Doppl dependencies. Then we have Android extensions. So for data storage, a SQLite database, shared preferences, threading is looper message queue handler, that whole thread, that whole stack. Then context, and by that I mean Android context, capital C, is implemented in part on iOS. Anything that makes sense, some things do not. There are annotations, so nullable, non-null, target API, suppress lint, what I call compilables, which is stuff that doesn't really have anything to do in iOS, but if you don't have it, your code may run into issues of not compiling because you want it for Android. And then question marks, some other crap that went away in there because something inside one of these other things depends on it. All this code came from the Android open source framework, so SQLite database was implemented on iOS using that same code, right? Same thing with the looper message queue. Some of it's modified. For instance, you know, for the main thread coming from iOS, you have to relinquish control back to the main thread, so the looper is somewhat different in this context. So that's that. And then we added testing support. So right now there's some instrumentation testing support. So in Android side, like maybe use Robo Electric to get a context that's usable in a testing environment. We created a similar thing in iOS, and then we have this delegate test runner that will, if you're in Java, will use Robo Electric, and if you're not, it'll use iOS. This isn't meant for like integration testing all the way top down, but really from your view model all the way down to your database and network calls, or just unit tests anywhere in between, right? Helper code, so things that'll help you run the JUnit test in an Xcode environment. Platform util, some other stuff. And then also which is some weird things. So like today, Mockito from J2OBJC supports mock but not spy, which was a little bit interesting. So in the very short term, we have a thing called mockgen, which will actually annotation processing generate a new class that's like mocked, which in retrospect is probably not the best way to go. Pretty soon after our V1-ish release, we're going to make sure we get Mockito fully running and some other stuff, but one day at a time. Testing support, and then Doppl libraries, and this is what Doppl is really from. It's short for doppelganger, right? We have JSON and Dagger, and they're pretty much 100% standard, and they run on iOS, no problem. Retrofit 2, and under the hood it uses OKHTTP, which actually was a problem on J2OBJC, and I've had several conversations with Jesse Wilson who wanted to get this to work, but at the end of the day, it was just a lot easier and safer to just use URL session in iOS, which is natively doing this stuff, and HTTP2 and SSL streams and all this kind of stuff. You just get it, right? And that's working pretty well. SQL Cipher, for example, is JNI in Java. It works on iOS, but you got a lot of iOS shit that you're actually doing. It's a long story. And then the architecture stuff, the new stuff, architecture components, room, view model, live data, whatever. That all works with Doppl libraries in the iOS context, right? And hopefully, if people in the community get into this, you can create your own libraries and publish them in the standard format. That will work with this tool, right? And then coming pretty soon, we have Xcode support. So it works with Swift, but setting up your Xcode project is not, let's say, pleasant. So we're going to have a thing probably after droidCon New York that comes out that helps you create an iOS framework from your code semi-automatically, and then you can just use it. So that's what's coming soon. Okay, great. That's what it is. But why? And the first thing is the obvious. It's just to don't repeat yourself. Code duplication is time-consuming and error-prone, and it just kind of feels wrong. I've been running Touch Lab. We have somebody here who's been at Touch Lab since 2010, and most of the work, since we were an Android-only shop for a long time, was really, here's our iOS app, make the Android app. And we're not going to pay you as much, and don't put all the features in, and don't redesign it. That's the conversations you have. So you're basically copying apps, and it just feels like, to be honest, shit work after 7 years. And it's just not the way to do it. And as a manager and a developer myself, if all you're doing is just a lot of copying, eventually maybe the good people don't stay around that long, So plenty of reasons. They're pretty obvious, I think, to a developer. These platforms are very similar. So fun fact, Android has a main thread and background threads. iOS has a main thread and background threads to do all the same UI and system stuff it does. It has SQLite, local files, networking, location. All these things exist on both platforms. I like to say that they are same methods, different names. And yes, iOS and Android are so different. It's like Coke and Pepsi, but at the same time, it's like soda water in a can. It's like the same thing, just different faces. So if you can imagine a theoretical thing that we'll call mobile VM, and you have an MVVM reactive architecture, and you have local DB and files and threading and networking and easy interop with a native code that doesn't get in the way of your daily life, large community with library selection, optimized IDE and support experience, and it compiles down to Android or iOS, and you can do Android Studio and Xcode to build your UIs. Imagine this thing existed, right? That's what that would look like. What we're doing is essentially doing that, subtracting one platform out of the mix, and just making Android that standard platform that will run on iOS. The Android apps are 100% native. There is no cross-platform code on there, and you get to use all these libraries and stuff, right? So it looks more like this. You got your native stuff, you got your fractivities at the top there, and then all of your architecturally bits here. And as long as you adhere to an MVX architecture and understand that you're going to have to share this code, you don't get into trouble, and you can pretty much do this. And then you just implement your stuff over here, right? Very clearly, though, this is not UI. And if you've been doing this long enough, I think every time somebody tries to come out with a cross-platform UI thing, it tends to just be garbage, right? I found this, it's like on the GTK website of here's our mobile implementation, look how great it is. And that's just trash, right? Or toilet implementation. I was having fun with Keynote. And I also, I just threw this slide in there because I thought this was hilarious, and it has nothing to do with the talk. That's for you. I hope you enjoy it. Okay. The next thing is smooth interoperability, and I think this is one of those things that is not really done well with any of the things that are out there. I'm sure some people who use the other things might disagree, but I'm going to explain why. It's natural intuitive. There's a Java interface that you basically can just talk to from both platforms, or probably an abstract class or whatever you would normally do. You can implement those things, either Java and Kotlin in your Android side and Objective-C or Swift on your iOS side. They're very easy to mix. Also, very importantly, you can share some of your code. You can pick what level of sharing you want to do, a whole ton or just a little bit, like maybe a complex piece. This also means the 2 weeks out from release nightmare issue. So if you're using some odd platform and you're 2 weeks out from release and something just isn't working, you don't really have that freak out moment. You just cut out the thing that's shared, you code it natively, and you fix it after release. So your escape route is much less scary, if you know what I mean. So we're going to talk about the Java shared code. We've got at the top, it is a view model that extends view model. This is like the new architecture stuff. And up here we've got host. Host is an interface, and this is what you're going to implement from your native UIs, and we kind of call back to them and do stuff, right? And then down here, when you call into this, it passes in a host. We wire up some, RX stuff, and when the things come back, we just pass that back to the host and do things with them, right? So on the left, you got your Kotlin, and notice the interface methods, data refresh. It does some stuff with the event info that comes back, and you got report error and update RSVP. And over here, this is what you're doing on the Swift side. And it's the same basic stuff, same methods, very similar looking syntax. In fact, Kotlin and Swift tend to share a lot of architectural similarities, at least and syntactic similarities, and what you can do with them. So there's another talk that I want to point people to when the video comes out, and it's just comparing that. So it's an interesting mix of things, right? So overall, what we're really trying to do is there's this Android, you got Android Studio and the Android architecture stuff that's coming out, and the community, like everybody's here, everybody's all over the place, meeting and getting together, writing libraries, Stack Overflows, all this stuff. And rather than building some third thing that you then have to build all these other things for, we're trying to leverage it and draft off it. So, we're the bike behind the truck, right? And as an example, I couldn't go to I/O for a long story reason I'm not going to get into, but they released Room, and then the next morning it took about 90 minutes to get Room working on iOS. And that's just an example of once you understand how these things mix together, it works out really well. Performance, you can't read it, but it's essentially, I did the database benchmark I did a couple years ago, and I ran it on Android and iOS, and in general, the iPhone would beat out a live Android phone, even sometimes comparable phones, except sometimes reflection kind of was slower in iOS, but that's a whatever. Okay, so the business case. And I'm going to go right through this real quick. There's a much longer analysis if you want to talk about it. I will go on and on, trust me. So the assumptions that I make are that native tools are the best for either platform. And by that I mean, if you were building an app that was only going to ever deploy on iOS, and you picked React Native as your development platform, and you had access to whatever developers you'd want, you would be crazy. And I say that because there's a thing that I call the platform tax. It's going to take longer to build the same functionality in this other platform, right? It's going to take, let's say, if it was going to take you 4 weeks to do an MVP on Android and Android Studio, it'll take you 6+ to do React Native or Xamarin or some other thing, right? And that is not an uncontroversial opinion to people who like React Native or other things, right? But it's not magic. And I talk to people who use React Native and other things, and it's not like it's all just roses. There's things, I just kind of threw this in because I thought that was hilarious. We get into a lot of arguments. It's the road less traveled in a lot of cases. So the library and support maturity, IDE and tools, the weird build and runtime issues, maybe missing features that are on these platforms, and what I like to call the WTF moments, where it just won't build. So the progression is do a clean build, and do a new checkout, then maybe reinstall your IDE, and if it gets really bad, go get a new laptop. You know what I mean? If this has never happened to you besides the laptop one, I don't know if you've been developing very long. So the weirder the platform you're using, the more likely you're going to hit these things. It's a little bit of FUD, I agree, but it happens. So yeah, the road less traveled for a reason. So, and then once you do that first piece of functionality, you still need to implement the other UI. Xamarin, pretty much 100% unless you use Xamarin Forms, you're going to have to build the other UI. React Native is still, like, you still do a lot of platform-specific stuff, right? Anyway, so which platform takes longer to build? And I'm at an Android conference, so I think people would say iPhone, and if I went to an iPhone meeting, they'd say Android. And it's a trick question, because the first one takes longer to build. Even with perfect specs, you're going to be testing and modifying architectural ideas, and you're going to be sorting out issues with your back-end team's API and all this stuff. Running a second platform shop for years, we can take advantage of this because the client already has an idea of what the first platform cost. So you can quote them, and they don't really kind of get the fact that the second platform is going to have a lot of lessons learned. But even that, there's no perfect specs, right? Agile exists because nobody knows what they want. So you're going to be doing a lot of work, and you're going to be throwing stuff away, and it is valuable waste. But it's still waste, right? And if you have this platform tax, this slower dev tax, it's on everything, right? So you're multiplying the damage you're doing. Like, I talk to people, and they're like, yeah, we're going to build native apps, but we're going to do a quick mock-up on React or HTML5 and get it out there and see what people think. And I just don't get that. I can't convince them that it's just going to be quicker to do a mock-up in Android Studio. But it is. I mean, yeah, you can't push that to iOS immediately, but you could just build a native app with some buttons and get the same feedback. So anyway, some people won't agree with that, but I say it, so see how it goes. Risk. Another part of the business case. Android in this framework is 100% native, and if we're being honest, Android is a riskier platform to deploy for, right? Some people don't like that statement, but it is true. There are many more phones and versions and all kinds of weird stuff going on. iOS, they have more screens now, but you can still count them. You know what I mean? Like, there's not that many. Sharing code is optional, so you can share a little bit, a lot, as said before, and you don't need to rewrite your apps or train a new skill set, obviously, besides running Doppl. So it's minimizing the risk. And then I have this other sort of argument, which is like, two UIs. Like, yeah, but we live in a world where everyone's still building two UIs. Until somebody figures out how to not do that, you got to do it, right? And then there's also this argument of, like, I think teams can kind of switch from being iOS and Android to be more like senior people are doing architecture and skeletal UIs, and you have more of UI teams that understand Kotlin and Swift and yada yada. It's a long argument. This slide is a toilet slide. I just didn't finish it, but we'll move on. And it's an important point. I'm just not making well for this talk, but come back next year. Okay, security. Again, sharing is optional. Sensitive endpoints can be handed off to native iOS stuff rather than trying to do it in some shared paradigm. I think this really helps with security. SQL Cypher was ported. There's kind of interesting encryption stuff going on. I've talked to people about React Native specifically in the context of security, and talked to someone who works at a bank, and their security people said, no way. I don't understand exactly why, and it might just be this fear of the unknown, but I'm trying to understand why. And we're trying to give an option that allows you to work around the really sensitive security bits. So the end of the story from the business case is, look, high efficiency, low risk. And the fastest product dev cycle time, and no compromise UX, low platform risk, and doing the simple thing. And it's a big decision to pick some third-party thing. And I've had good stories from React and Xamarin and PhoneGap and Ionic or whatever, but you're also going to hear horror stories with people starting over and just shit went wrong. And this concept is something that you don't have to hit the reset button if it doesn't work. And I think that's like the most important risk argument in this whole bunch, right? So let that wash over your mind. And then we have some fun little visuals. So, do the simple thing, don't get this weird complicated stuff, yada yada. So moving on. droidCon NYC iOS app, aka the sad puppy. We built this for 2016 droidCon, and we published it, and Apple said no, and I had a little screenshot that said Apple said it was not appropriate for the App Store because it said Android, and it had a little Android guy. So I made a quick joke and covered the Android guy with this little picture, and then I replaced Android with sad puppy throughout the app, And they said yes. So that exists. And first of all, I'm not like, I wish I had more time to do the joke because I didn't think they would take it. It's not a puppy, it's a full-grown dog. So the joke doesn't even really make sense. But whatever, moving on. So, but that app is old. And I found this commit from July 20th of 2014. And it's funny because we had two commits. First of all, we were starting Kotlin in 2014, which was like crazy time. And second of all, we also were trying out this retrofit thing. Like that's how old this the code that's in this app is. So even though it was using this cross-platform stuff, we had a bunch of homegrown libraries and event bus, and retrofit one, and non-retrofit networking, which is everyone remembers when you had to write your own networking libraries because that was cool. No RX Java and yada yada. So for the happy sad puppy's birthday, we're going to do retrofit 2. Well, we have done. This talk is old. We've done this stuff. RX Java 2 architecture components in Room, right? So very briefly, and I know that live coding is often a dumpster fire, but I'm going to show you view model with Android architecture components on iOS. So bear with me as I try to do this as swiftly as possible. And I'm going to mirror displays, and then we're going to go into here. And we're going to go into presenter mode. Okay. So if you look at the top here, we're going to implement, or at least see how the screen that shows you the detail of the speaker in our app is displayed. So we've got view model. We've got this interactor thing, which I won't get into. I'm not super excited about some of my team's choice of architecture, but anyway. Composite disposable, which is, if you don't know what these things are, don't worry. And flowable transformer, which is just going to apply the threading context we're going to use. So in testing, you don't have to do multiple threads, yada, yada. So we have an interface here called host. And host is the thing we're going to be talking to in the shared code. And if we don't find the user, we're going to post this method. And if we do, we're going to post this method, and the implementations are going to deal with it. Also notice that the non-null annotation, which is going to make Kotlin happy, and also J2OBJC passes that through, so Swift is also aware of these things. Okay, so in here we have a method called wire, and we pass in this host, which will be the native implementation, and we wire up these disposables, and when these things happen, or sorry, the observable, flowable, if we find the user, we pass that through to onUserFound, and if we don't, we call this method. I will point out that the way this works using Room is actually the open the flowable and keep that hanging around forever, so when you change the database, it gets pushed up to the UI, which I think is, a neat architectural thing. So, in Android, come on, buddy, user detail fragment. So here we've got the Kotlin code, and we got user detail view host, which we just talked about. We get our view model with a factory. We wire it by passing in this thing, which implements that, and we get a find your user ID, just goes and gets the intent and gets the ID. And then down here, we've got find user error, which does some error stuff. And we got onUserFound, which does some user found stuff. That's how that works, right? Really, really not super complicated. Is anybody lost? I'm going to assume not. Okay. Cool. So then in iOS, we have the user detail view controller. And if you're not aware of iOS, view controller is kind of like an activity. So there's that. But we're not implementing that host yet, and this thing is upset because it doesn't have the right stuff. So like every good cooking show, I'm going to show you pretty much something that's complete and just finish the implementation. So we implement host, and great. Now the self thing is happy because we're wiring correctly, but this is upset because we don't have the methods. So we're going to do find user error, and it's a demo, so I'm going to do nothing when we have an error. And onUserFound, and it passes in that thing, and I won't do anything yet. So we'll hit play, and I don't know, there's not really any important points here. Obviously, it's just creating this stuff as if it's normal Objective-C underneath Swift, which it is, and then these things work, right? So when we click in here, we go to this screen, and then nothing happens, because when the user came back, I didn't do anything. So, and when this happens again, it takes a little while. It's not quite a dumpster fire, but it's a little slow. There we go. So, and then, bam. No, no clapping? No, okay. Cool. Thank you. It wasn't really serious coding, live coding, but all right. So that's the only problem with this is now I got to find this guy. There we go. All right. So the status. We're in technical preview, which we did a month and change ago, which really just means it works, but it's going to change a lot, and I don't want to deal with people freaking out when it changes, but you can definitely use it. We are using it in live production apps for our clients. All of this is Apache 2, so I know that there were some recent licensing brouhahas going on in other parts of the community, and we all just decided to not get in any way involved in that. You can check out the tutorial and sample docs at that website, but you'll find it if you just go to the website. Quick note about libraries, like we used to be for a long time as Retrofit 1 because of OKHTTP, RxJava 1 because of it took forever to get that to work, but now Retrofit 2 is coming. That should be ready for public consumption by the droidCon, so a few weeks. Used to have a race condition a couple weeks ago, but I fixed it. It's amazing. Had nothing to do with Retrofit 2, by the way. And RxJava 2 works, but it still needs some work on memory kind of issues. So that should be following on in a few weeks as well. Also, weird edge case here, race condition, very edge case, but still figuring it out. And then the Swift help, again, as mentioned, I think most Android developers are not really going to want to get into this too much, figuring out Xcode, so we're going to try to help along with that. This sounds great, but there are issues, and this is mostly just the nature of J2OBJC. So I'm just going to tell you what they are. First of all, J2OBJC is not garbage collected the way Java is garbage collected. It is garbage collected the way iOS does garbage collection, which is reference counting. So if your objects reference each other in a cycle, you will have memory leaks. And when I tell that to Java people, it's like a hard pass, but I think you should know in practice, number one, it's not as often as you think. There are tools to help you with this in both J2OBJC and in Xcode toolchain, and also just like, hey, the iOS people have been doing this since day one. It's really not that bad, except RxJava. RxJava makes memory cycles like it was its job. That's a different discussion. We're working on it. There's some runtime size hit that comes along on the iOS side. And that's a long discussion, and it's difficult to figure out exact numbers because of the way Apple does all of its stuff. But it's generally not too bad. But if you don't have a lot of code that's shared, then you should not be using this. And that's just like a simple answer. I'll just tell you that. And it's going to be difficult if you're building a framework you give to other people to include this in the framework because it's going to add more weight than they would like. That's the way it is. And debugging, the code that gets produced in Objective-C is like kind of readable once you understand the pattern, but I wouldn't say it's super pleasant. So when you run into situations where you have something wrong in your shared code that wasn't wrong in your Android code, which thankfully is not like super common, it's a little difficult to debug. There are ways around that, but it's just one of those things that hopefully gets better over time. I will say that adding no extra weight to this shared code thing means that you don't have any extra problems on Android, right? So Instant Apps has that weight limit that is somewhat of an issue, so something to think about. You can kind of get around it. Great, but Kotlin and iOS is trash, right? I absolutely agree. So why should you care? And the answer is you shouldn't care, right? Kotlin is great. I still like Java though, but they're still awesome. If your team or your management or whatever is totally cool with just doing fully native dev, I don't think you should even really worry about this too much. And except for like rare cases, if you show up to your iOS team's like sprint planning meeting and you're like, hey, I got this really weird thing that's going to like do your job for you, like, it's not going to be something that they want. They're probably not going to like it very much, right? My general impression, my own included, is anytime someone presents a cross-platform thing to me, it's kind of like this, right? Nobody wants to hear this stuff. And we've gone into meetings with potential clients. They brought us in to talk about how do we best improve our developer efficiency. And we're talking to some folks, and then you go meet with the Android team. This happened recently, and the Android team was like, nah, we don't, that's Java, we don't want to touch that, we're going to do everything Kotlin from now on. The iOS team's like, yeah, no, thanks, we don't want to do that. And my point to them was, I'm not here for you, right? I'm here because the management people are now talking about crazy ideas, like, why do we need 2 apps? And I've heard about this other thing, and I've heard about React, and we should check this out, right? So I can still make an argument that doing something in a cross-platform framework is going to be slower than just building 2 apps if you do it a smart way. I can make that argument, but that argument doesn't sound very smart when the people that are like talking about the numbers don't understand the technology to begin with. So it's kind of one of those things where like, I think it's cool tech. I think we use it, and if you're building for multiple platforms and you're open to it, it's something that is cool and you should check it out. If you aren't super interested, but you start hearing grumblings from other parts of your team that, hey, we're going to check out this other thing, and we should really look at this, and making 2 apps isn't economical anymore, and I've heard about this awesome stuff, you should think about it. Because someday, you're going to suddenly be, hey, why don't you learn JavaScript and let's try this React Native thing finally. So my sales pitch is, in the meeting where they're talking about this, the safe option sounds like let's make 2 native apps, but it doesn't sound like the smart option. So give them the safe and smart option, Doppl salesperson. So that's it. Do you have any questions? Cool.
I wanted to compare this to the Xamarin thing, and from what I understood, it's just Xamarin has a third language that you compile to 2 main platforms, and you just have one that's already first-class language for one of the platforms. Mm-hmm. And also they have like the Xamarin Forms, but that doesn't count. So that's it?
Yeah. So why not Xamarin?
No.
Oh.
I mean, if that's it, then.
So it's a comment? Yeah. It's not so much a question? Yeah, okay. I mean, it's interesting. This goes back to about 1.5 years ago. We were working on this this thing called Research Stack, which is like the Android equivalent of Research Kit, which Apple built, which is a thing for medical research frameworks, which sounds great as long as you have an iPhone, right? So it was like, yet again, here we go, some platform-specific crap. So I started working a lot with Xamarin, and I love C#, actually. I think it's a great language. Xamarin Studio is, or at least was, horrendous. I think it still is pretty bad. And it's, I get really into this whole discussion of, yeah, these things work, but the developer efficiency is lower. So the discussion around them is usually like, hey, we'll get 2 apps for the price of 1, or 2 apps for the price of 1.5. But it's ignoring the fact that it's going to take you longer just to get anything done. And that's not inherent in Xamarin or C# per se, but the tooling around it and the libraries and the community and everything else involved is not necessarily as efficient. And that's the thing, like, there's a lot of talk about React Native, and I'm like, yeah, but Facebook doesn't have the same financial incentive to make React Native work that Google has in improving Android Studio, and that Xcode has in being better than everything else, right? So I don't know. It just seems to me like these things aren't going to be great. And then I also point out to people, like, you know how much of the Facebook app is React Native? Like none. You know what I mean? So it's a little like, I don't really trust it. And then there's stuff like Flutter coming out of Google. Google's kind of confusing about their messaging, and I describe it as it's like prison with a bunch of different gangs that fight each other, right? So politely. So one team at Google is going to say you should do progressive web apps, right? But until Apple decides that that's something that they want, which I don't see them doing anytime soon, like, I don't think that's really going to work out very well. And then they're like, oh, you should use Flutter. But it's like, until everyone is okay with one UI and not too worried about what happens when you need native stuff, like, I don't know. I don't see that thing taking over. They all have these compromises that I hope that we can figure out some better ways going forward to have less of. So.
Yeah, UI is just too complicated. That's why the Xamarin Forms, even like being 2.5, I guess now.
It's also a toilet thing, yeah.
Yeah, it's still a toilet thing.
Yeah, it's pretty bad.
Okay. Oh, yeah.
Cool.
Well, thank you.
Hey, I have 2 questions.
Yeah.
First of all, I saw you making changes to the Swift code that was generated. So if you made further changes to your Android app,
That wasn't generated code. That was the code that you write to wire your UI components into the shared code.
Oh, my bad then.
Yeah.
But are the files wiped every time you compile from Android to Swift? Or would you have system-dependent changes that would survive each compilation?
Well, so the design is that you really shouldn't change any of the generated code. You just can't, because if you do, it's going to get overwritten. It's definitely a one-way through. However, it's designed for, as you're iterating on the Java code, you just push everything over and it should keep up. Yeah, so just don't ever change the generated code.
Okay.
Ever. So.
Would you recommend doing the two applications at the same time to see if there's any bugs or changes, or would you just finish the Android application and then just hand it over to the iOS team if that was one of those?
I think that this all comes down to what you're building and how. So there's I don't know. In most cases, I wouldn't say, hey, build the entire app and get it out the door and then start on your iOS app. But I would definitely say that if you want to make sure you take twice as long to build an app, build both of them at the same time, because you're going to be making all the same mistakes. So if you can do a few weeks lead time on the Android side and sort out your architectural stuff and maybe do some user feedback so you can, there's a lot of stuff you just don't have to build on the second platform. But it all depends on what you're building. I definitely wouldn't really do them at the same time, so. Cool. All right.
I have one question. Is there something like the content provider provided by your tool?
No. And the issue with content provider is there are things that don't make sense in an iOS context, right? It depends what you're using content provider for. I also am somebody who's not a fan of content provider because it turned into a thing where everyone used it all the time, even if you weren't sharing data outside of your app. So I always found it to be this architectural extra work. And not everyone agrees with me on that, I get it. But I think in that case, if you really wanted to use a content provider, what you can do is the code that's actually going to be taking the URLs and parsing them and dealing with the SQL and doing all that, put that in shared code, and then just have your content provider and your platform-specific code that can call into it. And then in iOS, you would just call into it, which is the whole point of optional sharing. And it's very easy to do that kind of sharing architecture. But unless I'm wrong, I don't think you can just expose data to other apps in iOS. That wasn't an architectural purpose that they had, But it's also good because unlike other platforms, every time there's a new version of iOS or Android, you don't need to rewrap all the bindings. We're just trying to do the 80-20 rule, where you share a bunch of stuff, but don't lose your mind and try to share everything. So that was sort of the architectural mandate, for lack of a better word. Anybody else? We are in the phase of please go try it. If you're remotely technically curious and like to see weird stuff, I know this seems weird, go clone the app and build the Android droidCon app and see what it's doing. And if you want any help, go on the little Slack group or find me on Twitter. I will absolutely, I'm super invested in making this happen. It's not just I want this to happen. I think, I don't really think that Google or Apple or in some cases Facebook is necessarily going to build the thing that's going to it's going to have to come from a little more from community, a thing that helps us to build better. I could be wrong. Google might come out with here's the Kotlin share everywhere and everything works and it's super awesome. I could be wrong. But it seems like that is not their focus. And in as much as this may be useful for the developers out there who have to be more efficient in development, it's going to take people trying it, and it's going to take community feedback, and then hopefully we can work on the next thing and the next thing and whatever those are. But, that's my plea to the world. Please try it out. So, yeah, that's it. Thank you very much.